Today, folks, we are going to review for an exam. Now, the exam is going to be over section 8.2 through 8.5, and we're going to focus today on what topics you're going to see in that test. So, your note today, as you see it, to review for a test over sections 8.2 through 8.5, and when we're all done today, you will have a little idea of what you need to study to be prepared for this exam. There are 8 topics that we're going to be looking at today, of which the first one is to simplify rational expressions and to restrict a domain. So let's take a look at an example of what you might need to do on this exam. So let's say, for example, that I give you a question, and let's say that it looks like x squared plus x minus 6 on the bottom, and on the top, let's say we have an x minus 2. Now, with this type of situation, the first thing you always do is factor the numerator and denominator. Now, if you take a look at the numerator, can we factor the numerator here? Well, it's x to the first. Normally, when you see x to the first, it won't factor, provided there isn't anything that'll factor out. And there's nothing common to both these terms, so that means no, nothing will factor out. So now we take a look at the bottom. Notice there's 3 terms on the bottom. Well, 3 terms, and this is an x squared here. It's a trinomial, so actually you can look at this and you can see, yeah, you can tree this out. Okay, so, and the factors of this are going to be negative 2 times 3, negative 3 times 2, and negative 1 times 6, negative 6 times 1, but we already found our answer, and it's actually this one right here. Okay, so let's go ahead and factor that. When I factor that, the top is going to be x minus 2, and the bottom is going to be x minus 2, x plus a 3. Alright, so there it is. Now, at this point, we're going to look to see if there's anything that'll divide out. And you know what? It just so happens that yes, there is something that will divide out. But before we divide stuff out, let's take each of our factors in their denominator, and we're going to set them equal to 0. Now, why do we need to do that? Well, we need to determine if there are any restrictions to the domain. And in this situation, was there a restriction to the domain? Well, yes, there are 2 values that could cause the denominator to go to 0. The first one is, I see that if I add a 2 to both sides here, I get x is equal to a 2. And over here, if I subtract a 3 to both sides, I get x is equal to a negative 3. So I see that there are 2 numbers that could cause the denominator to go to 0. Alright, next thing I want to do is I want to divide out. So I see that there's an x plus 2 in the top here, and an x minus 2 in the top, and an x minus 2 here. So I'm going to go ahead and divide those out. So let's divide those out like this. And it turns out that I only have an x plus a 3 on the bottom. And on the top, what is left? Well, sometimes you may say, you know, there's nothing left there, so it's 0. But no, that's not true. Remember, when things divide out, remember, x minus 2 divides into x minus 2 one time. So there is left, so let's go this way with this. So there is left a 1 in the top and an x plus 3 in the bottom, and then you're going to put a little comma there, and that's where you're going to write x is not equal to 2, and x is not equal to a negative 3. Okay, so x is not equal to a 2, x is not equal to a negative 3, and this is our final answer. For our second topic for today, let me give us a problem. Let's say that I have, an x minus 2 over an x minus 3 plus, and then I have an x over an x minus 3, and we'll say an x minus 2. Okay, now, in this situation, and let's extend this so it looks like it's all the way over it. In this situation, we need to determine, okay, what's my denominator here? X minus 3, x minus 2. What do I have over here? X minus 3. I need a denominator that is the same So I need a common denominator. In order to find a common denominator, I need to identify what the LCM is of this and this here. All right, so let's come up here and let's just play with it a little bit here. And let's find the LCM. So first of all, I am going to make a list of the factors. I have an x minus 3 for a factor, and it turns out that I have an x minus 2 for a factor as well. All right, so let's just compare here. How many x minus 3's do I have here? Well, 1. How many x minus 3's do I have here? 1. So that means I'm going to take one of them. Okay, so over here I have 1 x minus 2's. How many x minus 2's do I have here? None. So that means I'm going to take 1. All right, so this here is our common denominator, our LCM, which becomes our common denominator. All right, so now I am going to go down here and I'm going to rewrite it here so that I have my common denominator. So x minus 3 and an x minus 2 and an x minus 3 and an x minus 2 right here. All right, so now look here. What do I have right here? An x minus 3. What do I have down here? X minus 3, x minus 2. If I compare these, what's missing? Well, hopefully you say, oh, you're missing an x minus 2. That is right. That is what I'm missing. So that is what I will need to multiply the top and bottom by. So I'm going to multiply top and bottom by x minus a 2 over x minus a 2. All right, now I'm going to put parentheses around that because each of those are binomials. Okay, so on the top here, I will have an x minus 2 times an x minus 2. Now, let's compare over here. What do I have? X minus 3, x minus 2, x minus 3 minus 2. Is there anything missing? Nope, they look the same. So I'm going to just take this x and I'm going to carry it down and put it right there. So I'm going to just put my x right there. Now that I have a common denominator, okay, notice x minus 3, x minus 2, x minus 3 minus 2, since I have a common denominator, I can simplify my numerators. So let's go ahead and do that. So in doing that, I will have, and I'm going to write it with just one denominator here, so x minus 3, x minus 2, and on the top, x minus 2, x minus 2, plus an x. Now, let's see, what do I need to do to simplify this numerator here? Well, to simplify that numerator, we need to, well, I have to get rid of parentheses first. How do I get rid of parentheses? Well, we're going to get rid of parentheses. Let's see, I need to distribute. Okay, so I'm going to have x squared minus a 2x minus a 2x plus a 4 plus an x on the top, and on the bottom, leave it as it is. Do not multiply that together. So we're just going to leave it like that. All right, so now from here, what do we do? Well, let's see. Do I have some like terms? Well, I have an x, yeah, those two are like terms, and then I have a like term over here. So let's add those like terms together. So I'm going to have x2, and now let's think here. Negative 2x minus 2x is negative 4x plus x is negative 3x. So I have minus 3x plus a 4 over top of x minus 3 and then an x minus a 2. Now at this point I might be almost done, but before I just say that I'm going to be done, I need to find, can this thing divide out, which means I need to factor my numerator here. So let's just go over here a little bit and let's go, okay, let's go x squared minus a 3x plus a 4, and are there any factors of 4 that, now notice here, don't forget, this is a plus, this is a minus, are there any factors of 4 that will add up to give me a negative 3? Well, let's see. You know, we have negative 2 times negative 2, you have negative 1 times negative 4, you have negative 4 times negative 1, and no, none of them are. So what does that tell us? Well, that tells us that it cannot be factored, therefore this is our answer right here. Now go back to the directions, so let's look at the directions, and does it tell us to restrict the domain? Because if it does, then we have to set the denominator equal to 0 and solve. And I don't see that it does. So, at this point, you are finished. Okay, in this topic, we're going to look at multiplication and division of rational expressions. So, I'm going to give you a problem, and let's take x minus a 2 over x minus a 3. And we're going to do a division problem because the difference between division and multiplication is one teeny little step, and then it turns into a multiplication problem, and we're going to talk about it here in a second. Then I have x squared. Let's go say minus a 5x plus a 6. Alright, so now the first thing we must do is, and we call it a property, but it's actually not. It's just kind of our little nickname here. It's called the KFC property. Now, what is the KFC? Well, that means we're going to keep this the same. I'm going to flip this, and we're going to change this right here. Okay, so let's go ahead and do that. So the K stands for keep it the same, so x minus 2 over top of x minus 3. The F stands for flip, so we're going to flip this, so it's going to be x squared minus a 5x plus a 6 all over an x. And then we're going to change the division to multiplication. Alright, so there we go. Now, what are we going to do from here? Well, ask yourself, well, we have to factor the whole thing. Well, this factor right here, well, it's to the first power, nothing factors out, no. What about this? Same thing, no. What about this? Same thing, no. Oh, here I have an x squared, and there's 3 terms. Is there a common factor there? No. Okay, so next, is there any factors of 6 that will add up to be a negative 5? Well, remember, this is a plus, this is a minus, so both of the factors here are going to be like things like negative 3 times negative 2, negative 2 times negative 3, negative 1 times negative 6, negative 6 times negative 1. Do any of those add up to be a negative 5? Well, yeah, the first 2 I mentioned did. So let's go ahead and factor that. So here, this is going to be an x minus a 2 over an x minus a 3 times, and up here, this is going to be an x minus a 2 and x minus a 3 all over x. Okay, we've factored it everywhere. Now, will anything divide out? Well, let's compare here. If I take a look at this, x minus 2, is there an x minus 2 down here? No. Okay, but something that you guys, this is a mistake you guys, I've seen you make in class. See this x minus 2 here, x minus 2 there, you seem to think you can divide those out. But notice they're both in the numerator. The only thing you could really do to those is multiply them together. Okay, so you don't want to divide them out. Okay, so anything else up here? Well, I see an x minus 3. Oh, and we see an x minus 3 there. So that's going to divide out. So those divide out. Now, I see an x. And do I see an x here? Now, some of you might think, oh yes, we see an x right there. Or an x right there. But no, that's not true. This is an x minus 2. This is an x minus 2. And this is an x. They're not like factors, so you cannot divide them out. So what do you do from here? Well, you just shove it all together, and we're pretty much wrapped up, finished here. So let's go ahead and let's shove it together. So on the top, I'm going to get an x minus 2. Now, you could write it out, x minus 2, or you could put it as x minus 2 squared divided by an x. Now, we might be done, but let's go up and read the directions. Did it ask us to restrict the domain? The answer is no, it did not. So, that means I am finished. For topic number 4, we're going to look at simplifying complex rational expressions. Now, remember what a complex rational expression was. It was an expression where there is a fraction or a rational expression in the numerator and one in the denominator as well. So, what does that mean? Well, it looks something like this. Let's say that I have an x minus 2 over an x minus 3 all over, and then I'm going to have an x, and let's use the same one that we did in the last topic here, and I'm going to take an x squared minus a 5x plus a 6. Now, remember here, this right here just means what symbol? Well, hopefully you guys said it's the same as a division symbol, like this. So we're going to write it that way. So I'm going to have x minus a 2 over x minus 3, and I'm going to type the division, or put the division symbol there, and over here I'm going to have x over x squared minus a 5x plus a 6. Alright, now, what do we do from there? Well, guys, it's the same as topic number 3 that we just did. Okay, this problem is the problem you just wrote down in your notes. Everything from that point forward is the same. In other words, here's what we did. We took this, and I factored everything, and I KFC'd it. So I'm going to go ahead and combine those steps a little bit here. So when I factored it, it came out to be x minus a 2, x minus a 3, all over an x. We looked and asked ourselves, will anything divide out? You said yes, this x minus 3 is divided out. And what was left on top? Well, let's see. We were left with an x minus 2, the quantity squared, over an x. And ta-da, we are finished. For this topic, I'm going to be asking you how to find the least common multiple. Now, we did this a little bit in slide number 2, topic number 2, when we added and subtracted rational expressions. But on the test, I am going to give you something, for example, like this. I'm going to give you a polynomial, like x minus 3. And then I'm going to give you a polynomial, and this time let's go x squared plus an x minus 6. So we're going to change it up just a little bit. Now, the first thing you need to do, step number 1, is you need to factor this polynomial and this polynomial. So factor them first. Now, after you factor them, let's see. Will x minus 3 factor? Well, it's to the first power, so probably not. But let's make sure, is there a GCF here, greatest common factor? And the answer is no. So it will not factor. So I'm going to just write down x minus a 3. Now, over here, let's factor this one. Okay, well, in looking at this one, it's x squared, so probably will factor. So it's a trinomial, so we need to tree it out. So are there factors of negative 6 that will add up to be a positive 1? So let's think. Let's say we have negative 3 times 2, negative 2 times 3, negative 1 times 6, negative 6 times 1. Do any of those add up to be a 1? And the answer is yes. I have, let's see, we did negative 2 times 3. So let's go ahead and factor that. So let's go over here, and we're going to say x minus a 2, x plus a 3. All right, now let's make an inventory, make a list of all the different factors we have. Well, I have an x minus 3 factor, I have an x minus 2 factor, and I have an x plus a 3 factor. So I have 3 different factors. So I'm going to make a list of these 3 factors here. So let's put an x minus a 3 right there. And then I have an x minus 2, so I'm going to put that one there. And then I have an x plus a 3, so I put that one there. Now, from here, I want the most of each factor. So what is the largest number of each of the factors? Well, look here. How many x minus 3's do I have here? Well, you say 1. Do I have any x minus 3's over here? No, I don't. So since I don't, I'm going to take one of them. All right, so let's go to the next one. I have one x minus 2 here. How many x minus 2's do I have over there? Well, I don't have any of them. So how many am I going to take? 1. All right, now we have 1 x plus 3 over here. I have 0 x plus 3's there. So I'm going to take the largest number of those, which is 1. So what is my LCM? Well, guys, it's just going to be this whole thing put together. So my LCM is going to be x minus 3, x minus 2, and x plus a 3. And there is our LCM, least common multiple. For our sixth topic today, we are going to look at how to solve rational equations. Now, let me give you a problem, and then we're going to walk through it. So let's start with this. Let's say that I have a 2x minus 9 over top of an x minus a 7. Plus, and then let's have an x over 2, and that is equal to 5 over x minus 7. So there's our rational equation. Now, remember what a rational equation is. A rational equation is a situation, a problem, where you have a rational expression on both sides of the equal sign. And it turns out, now each one of these is a term. So I have a rational expression plus a rational expression, so there are two terms here, equals a rational expression. Now, we have a fraction. With it being rational, that means we have a fraction. I do not want this denominator down here. I want to get rid of that. How do I get rid of that? Well, in getting rid of that, what I'm going to do is I need to ask myself, what is my least common multiple of each of those denominators? Because my least common multiple is going to become my least common denominator, and I'm going to multiply all three terms, this one, and this one, by that least common denominator. All right, so let's go ahead and let's find the least common denominator. So, to find my least common denominator, I'm going to list each of the factors of x minus 7, 2, and x minus 7. So, I have an x minus a 7, and what else do I have? Well, I have a 2. Do I have anything else down here? No, I do not. Okay, so let's look. How many x minus 7s do I have here? 1. How many x minus 7s do I have here? None. How many do I have here? 1. So I'm going to take one of them up there. So how many 2's do I have here? None. How many 2's do I have here? None. How many 2's do I have? Ooh, back up. How many 2's did I have here? I had one of them. Do I have any here? None. Okay, so what does that mean? Well, I'm going to put 1 up there. And that's all my factors. All right, well, now, this here is my LCM, which becomes my LCD, and I'm going to multiply each of these terms right here by this LCD. All right, so let's go ahead and do that. So let's see here. Let me choose a purple color here, and I'm going to take 2 times the quantity, x minus a 7, and I'm going to times that by all three terms. So that means I'm going to times it by the 2x minus a 9 over the x minus a 7 plus, and then I have 2 times the quantity x minus 7 times, and I have an x over a 2 equals, and then I have 2 times x minus a 7 times, and I had a 5 over top of x minus 7. Now I want to divide things out. Is there anything that'll divide out anywhere? Well, let's see. I have a 2. Is there a 2 down here? No. I have an x minus 7. Is there an x minus 7 down here? No. I have a 2x minus 9. Oh, hold it again. What do we see here? I see an x minus 7, x minus 7. Those divide out. So, let's divide those out. So, x minus 7's divide out. What about this? 2x minus 9? No 2x minus 9. Okay, so that's it there. And this will just become here. I have a 2 times 2x minus a 9. All right, so now let's take a look at that second term. What do I have? A 2? Do I have a 2 down here? Yeah, there's a 2. Okay, so let's divide out those. So these two divide out. And what am I left with here? X minus 7 times x. Okay, so let's write that down. And you know, as I write that down, I'm going to put the x first in front of the x minus 7. Why? Well, the community property multiplication says I can do that. Why again? Well, because I like to distribute my x inside rather than distribute my x minus 7 to my x. All right, so what's left over here? Well, is there anything that divides that here? There's a 2 up here. Is there a 2 down there? Nope. Okay, there's an x minus 7 up here. Is there an x minus 7 down there? Is there? You betcha there is. All right, so let's divide that out. So this x minus 7 divides out with that x minus 7, and what does it leave me with? Well, I have a 2 here and a 5 there. So altogether, that becomes a, yes, you said it, a 10. Now, what do I have here? I have a great big old long linear equation. Is it a linear? Well, it looks linear now because everything's to the first power. But then look again, what's going to happen right here? Ooh, it looks like it's going to become quadratic. All right, so let's just simplify this equation. We're going to see just what happens here. All right, so let's go ahead and take this one. So it becomes, distribute that inside, that gives me a 4x minus 18. Plus, distribute this x, so that becomes x squared, that's what makes it quadratic, minus a 7x equals 10. All right, now remember, some of you still have a hard time seeing what way we need to solve it. This is a tale teller right here. That x squared tells you it is a quadratic equation. Once you have a quadratic equation, you need to set it equal to 0. You need to get everything on the left side with 0 on the right side, and then you have to factor it and solve it. So the key here again, if it's a linear x to the first and there's nothing but x to the first all the way across, you just get x by itself. However, if you look across here and you see an x to the second, automatically you know you have to put everything on the left side, set it equal to 0, and factor it. So that's what we're going to do. So let's get some more room here, and we're going to add like terms. Is there any like terms here? Yes, look at this, 4x and negative 7x. And as I add like terms, I'm also going to put it in descending order. You may say, well, what was descending order again? It's where you have the largest terms first. So in other words, you're going to put the x squared first, you're going to put the x's second, and you put the numbers third. All right, so let's go ahead and do that. So I have x to the second. We're going to add this 4x minus 7x minus 3x minus 18 equals 2a10. Now, what did we say had to happen? Well, if you said we had to set it equal to 0, you are correct. So I'm going to subtract 10 to both sides. And in doing so, that gives me x squared minus a 3x minus a 28 equals to a 0. Alrighty, what's next? Well, guys, it's a quadratic equation. We first ask ourselves, is there anything common to all three of these terms? And your answer was no. So what are we going to do? Well, I'm going to tree it out and factor it. So what factors of negative 28 will give me a negative 23? So let's see here. How about negative 7 times 4? Yep, there it is. All right, so let's go ahead and write that down. So I'm going to factor this, and it's going to be x minus a 7, x plus a 4 equals to a 0. All right, now, what's left? Well, let's, what is that property called where we have to set each one of these equal to 0? Anybody remember? If you said the zero product property, you are correct. So that's what I'm going to do. I'm going to set this factor here equals to a 0. I'm going to set this factor here equal to a 0 and solve for it. So we're going to add a 7 to both sides. And you get x is equal to a 7. Going to subtract a 4 to both sides. And you get x is equal to a negative 4. And voila, there it is. Or is it? Remember, guys, remember when we talked about extraneous solutions? You have to check each of these to make sure they work, because they might be extraneous. So let's go back to the original problem and let's see if they work. So let's just go back and let me write down that original problem again. It was, here, let me change pen colors. It was a 2x minus a 9 over top of x minus a 7 plus x over a 2 equals a 5 over, what was it, x minus 7. All right, so let's take a look here. Let's do the 7 first. If I take that 7 and let's plug that 7 right in there, and what happens? Yes, this goes to 0. What does that tell you? Well, you're saying undefined. You cannot divide by 0. So that means 7 is what? Yes, it's extraneous. See if I can spell extraneous here, so we can cross that out. It's extraneous. Now we're going to try negative 4. Will negative 4 work? Well, let's go ahead and test it, plug it in, and see what's going to happen here. So I have let's see, I'm going to have 2 times negative 4 divided by negative 4 minus 7 plus negative 4 over 2 equals 5 over negative 4 minus 7. All right, let's simplify that and see what that comes out to be. So if I simplify that, that gives me what here on top? I have a negative 8 on the top. On the bottom, 7, 8, 9, 10, 11, negative 11, plus here I get negative 2, and on the bottom over here I get 5 over negative 11. All right, now let's simplify this. Oh, don't forget, we have this negative 9 right there, so let's subtract 9 right there. Subtract 9 right there. So what does that give me here? Well, let's see here. We have here, it looks like I have negative 17 over negative 11. Two negatives make a positive. Then I have minus, and because of this 2 here, I need to get a common denominator, so I'm going to multiply by 11 over 11 here. So let me see if I can write that in there. 11 over 11, which makes this a negative 22 over 11. And we're going to see if that equals negative 5 over 11. Okay, so let's see. Ooh, look at that. 17 minus 22 is negative 5 over 11, which is negative 5 over 11. Wow, look at that. It checks out. So what does that tell me my answer is? Well, let me change pen colors here. Let's go back to purple. And I can see that negative 4 does work, so we're going to put it in set builder notation, and voila, there's our answer. For our very last topic today, we are going to look at graphing rational expressions. Now, there were 2 types of rational expressions that we graphed. One was a hyperbola, and the second one was just a rational equation. So what we're going to do today is we are going to take a look at a rational expression. All right, so if we do a rational expression, let's start with this one right here. Let's say that I give you f of x, so I'm calling it a function, is equal to x all over, and we're going to take x squared plus an x minus a 6. Yeah, that's familiar with what we've done. We've done that one kind of up above a little bit. So, first step you need to do is you need to, so step number 1, factor it. Okay, so let's factor it. So we're gonna have f of x equal to, you have x on the top and on the bottom. It's going to be x minus a 2, x plus a 3. Okay, now let's see, what's we didn't do from there? Okay, well let's go to step 2. Step 2, you're going to find the zeros of the function. Okay, so we need to find the zeros. And to find the zeros, you're going to take the numerator. Okay, take the numerator, set it equal to 0, and solve for it. So I'm going to take x, and I'm going to set it equal to 0. Take my numerator here, set it equal to 0, and solve. And guess what? I just get x equals 0. That means the function crosses the x-axis at 0. Let me say that again. The zeros of the function is the spot where it crosses the x-axis. So it crosses the x-axis at 0. Let's go up here, and I'm going to start graphing this just a little bit here. So, okay, we have this. And let's just kind of tick it off a little bit here. So let's go 1, 2, 3. Okay, and now always remember, when you graph, always scale it. Okay, so that's going to be a 4 up there, and down here 1, 2, 3, 4. So always scale it. So start with something like that. Now, we've found so far that it had 0 as one of the zeros of the function. Okay, so I'm going to put that there, and I'm going to put a little 0 there as well, because that labels, that is my x-intercept. Okay, so what's next? Step number 3. Well, step number 3 is you need to find your vertical asymptotes. Okay, so vertical asymptotes. Now, to find the vertical asymptotes, you are going to set the denominator equal to 0 and solve. Let me say that again. you're going to set the denominator equal to 0 and solve. In other words, I'm going to take this right there, and we're going to set each one of those using the zero product property. We're going to take each of those factors equal to 0 and solve. So when I solve this, I see that it's going to give me, let's see, we're going to add 2 to both sides, and I get x is equal to a 2. Over here I'm going to subtract 3 to both sides, and I get x is equal to a negative 3. All right, I have 2 vertical asymptotes. Maybe. Okay, maybe. Why do I say maybe? Well, remember something called a hole? If I look up here and if the factors divide out up here, it is a hole. Do I see any of x minus 2 or x plus 3's divide out with a numerator? No. So that means both of these are vertical asymptotes. So now, when you write down your vertical asymptotes, make sure you say it this way: x minus 2, x minus negative 3. Don't just put 2 and negative 3, because your vertical asymptote is a vertical line. So it has to show it x equals 2 and x equals negative 3. So let's go ahead and put those on our graph here. So let's see, we had an x equals 2. So I'm going to go over here, and I'm going to make a dotted line here. So let's do that in red here. So we had x equals to a 2. So I'm going to make a dotted line that runs right down through here at 2. Okay, notice how long I'm making it. And I'm going to go ahead and draw a little picture to it. So this here, or a little pointer to it, so showing that is x equals a 2. And then I'm going to go over here to x equals negative 3, and I'm going to do the same thing. We're going to just bring right down there, and I'm going to draw a little picture to it as well, because this, or a little pointer to it as well, so this is going to be x equals a negative 3. All right, now, what's my next step? Well, we need to find the horizontal asymptotes. Well, horizontal asymptotes. Remember, you had a chart that showed us that. So, step 4 is we want to find the horizontal asymptotes. So, to find the horizontal asymptotes, we needed to look right here and determine something. What was my degree of my numerator? Well, if I look at my leading term, what's there? Well, you know there's an imaginary 1 that's there. Okay, so that's a degree of 1. What's the degree of this polynomial in the numerator or denominator? Well, it is a 2. So here's what you needed to remember. Remember your p of x over q of x? And I'll just write them out, or I'm going to say them out here. You can go back to your notes to read it. If p of x is greater than q of x, there was no horizontal asymptote. If p of x was less than q of x, that means your asymptote was y equals 0. So that's what it is in this situation. And the third one is if p of x equaled q of x. Then it was a ratio of the numeric coefficients. All right, so I see that this numerator has a degree here of 1. This denominator has a degree of 2. That means my horizontal asymptote is going to be y equals 0. So let me go ahead and we're just going to write that down here. So I have y equals 0. Okay, let's go up to our graph, and I am going to put that on there. And I'm going to do it in red. So let me change this color here. Okay, so here is my horizontal asymptote. Right through there, and of course I'm going to label it by saying y equals 0. Alright, now at this point, what are you going to do to figure it out? Well guys, at this point you needed to use your graphing utility, either the Inspire, whatever your graphing calculator is, or possibly your device. Okay, now remember when we take the test, I am going to let you use your device on the test. However, we're going to have to put it in airplane mode first, though. So, let's go ahead and graph it. And you know what? I can't show it on the screen here, but if you were to go ahead and pause it for a second, plug this into your calculator, and see where the graph is. You know, is it going to be down here? Is it going to be up here? Where is it going to be here? And where is it going to be over here? Okay, go ahead and pause it and graph it. All right, now that you've graphed it, where was it? Well, if yours was anything like mine, it was in this location right over here. So let's see. It was here. Okay. It was there. And it went here. Now remember, it went through 0, so it was here. Went something like that. And then it did something like this. Okay. And remember, it just got close to the vertical asymptotes, and it also got close to the horizontal asymptotes. It did not cross it. And there is what our graph looks like. This is going to wrap up our review. Hopefully you've taken good notes over each of these topics, and it's kind of brought the whole chapter together for you. When we come together next class period, we are going to look at we're going to practice some problems, and we're going to do it with our group, and then we're going to be taking a test. So the test is going to be in 2 class periods from now. So anyway, let's go ahead, and I'm going to give you a so long farewell and happy studying.